either communication or skywave propagation. These are all used interchangeably. So please visit these three websites at your leisure, so you will get a general overall idea from this. Now let me come to ionospheric propagation. What is ionosphere? It refers to the upper region of the atmosphere, which is from about 90 to 1000 kilometers. So that range is called ionosphere. Why this is called ionosphere? The name comes from ion. In this range, you will get many charged particles, which are ionized. Charged particles means ionized particles. So this region is highly ionized. It has high density of free electrons, which are negatively charged. As you know, electrons are negatively charged, and positively charged ions. Now, from where these electrons and positively charged ions come? To understand that, let us start at looking what is around the earth. Now the earth gets its most of the energy, or almost all the energy comes from sun. So we have sun. So from sun there is radiation, or from sun we are getting electromagnetic energy. They are coming towards earth. Now earth is covered by its atmosphere. The atmosphere is very dense when it is nearer to the surface of the earth. The density goes on decreasing as you go away from the surface of the earth, or as we go upward from the surface of the earth, the density keeps on decreasing. Density of the atmosphere. Atmosphere consists of gases, different types of gases, and particles which are coming from cosmic. So cosmic particles and gases constitute the atmosphere. Now, from when these rays are coming from the sun, they will meet the atmosphere first. The outermost layer of the atmosphere, they will meet the rays of the sun first. Then that will penetrate through the atmosphere and come to the surface of the earth. Now, in this process, what happens that you have to consider? When it meets, when the atmosphere, outer part atmosphere meets the sun rays, at that point the energy contained in the ray is maximum, because it is not attenuated by the atmosphere. So it is directly coming from sun. So we get maximum energy at the outer surface of the atmosphere. Now as it penetrates through the atmosphere keeps on absorbing energy from the ray. By the time it comes to the earth surface, that there will be lower energy or minimum energy compared to the surface of the atmosphere. So on the surface of the earth we get minimum energy. On this surface of the atmosphere, outer atmosphere, we get maximum energy. Now the more the energy, the moment you excite any gas particle or gas with energy, gas consists of many different molecules. So when they are energized, the electrons get detached because of the energy. Depending on what is the EV, electrons will detach from their molecules. The moment they are detached, we get free electrons, which are negatively charged particles. Also you get electrons. Now they have detached from their original molecule. So the molecule from which it has been detached becomes ionized. It becomes a positively charged particle. Now if you compare these two, electrons have lighter mass compared to the ionized portion, or which is the ions of the gas molecules, which are ionized. So in the atmosphere there will be a portion in which where this will occur. Now this will occur very on the upper atmosphere or on the lower part of the atmosphere. That is the question that we have to see. Now in the upper part of the atmosphere, the density is minimum. Since density is minimum, there will be minimum number of gas particles. So ionization will be minimum there. Now when we come to the surface of the earth, the lower portion of the atmosphere, which is in contact of the surface of the earth, density is maximum, but energy which is going to ionize it is minimum. Therefore there will be no ionization. So on the surface of the earth there will be no ionization. On the outer surface of the atmosphere there will be no ionization. Then what will happen? The ionization will be in between these two. So as you go from the surface of the earth upward, energy is increasing, density is gradually decreasing. So there will be a region in which there will be sufficient density as well as sufficient energy to ionize the gas particles appropriately. So that region of the atmosphere is called ionosphere, because in that region the particles, gas particles, are ionized. Because that region consists of ionized gas particles, that region is called ionosphere. That extends from 90 km to 1000 km. Now because these are charged particles, they have been charged, it contains charged particles, that is going to affect the electromagnetic propagation. So if you are trying to have a communication link and the wave tries to pass through that region, there will be some effect on the electromagnetic wave. In this course we are going to study what are the effects when the effect of Earth's magnetic field is negligible. Then we will consider when the effect of Earth's magnetic field is appreciable, which cannot be neglected. So initially we will consider initially we will neglect on the effect of Earth's magnetic field. Now this variation in electron density, N is electron density, N is number of electrons, E is for electron. So Ne is number of electrons per cubic meter. That is why we call it electron density. This is in the atmosphere or in the ionosphere. So Ne is number of electrons in the ionosphere per cubic meter. So variation of electron density, that causes the wave to bend towards the earth. So if we are sending a wave from earth to in the upward direction to the sky or free space, it will bend back under certain conditions. We will see later. It will bend back towards the earth. It will go there, then come back towards earth. Only under certain frequency and certain angle of incidence. So not for all angle of incidence this is not going to bend, or for all frequency this is not going to bend. So those conditions are to be satisfied. We will see those conditions in a minute as we go onward. Now let us look at the electron density profile in the. You can easily remember this, or you can easily apprehend this. In the daytime the sun is present, therefore energy is maximum. In the night time sun is absent, but there will be some amount of energy, because in the daytime the atmosphere has absorbed energy, so some energy will be there. There will be available in the atmosphere, free atmosphere, or in the ionosphere there will be some energy. So because of that, in the daytime the ionospheric layer, thickness of the ionospheric layer will be more compared to the thickness of the ionospheric layer in the night time. So this picture shows electron concentration or electron density Ne in cubic centimeter is in the x-axis. In the y-axis shows the height from the surface of the earth. Now if I look at this, you can see there are two boundaries. One boundary is for day, one boundary is for night. So beyond this boundary, beyond these two boundaries, there will be no ionization. Within these two boundary only there will be ionization. And you can see from the height there is a knee. It looks like a knee, one boundary. As you go in the upward direction, particularly at that height, we get a larger thickness of electron concentration. So it is between 10 to the power 4 to 10 to the power 5 in that region, around 10 to the power 10 into 10 to the power 4. So in that region you will get a band like structure. So beyond that there is no need. Now these layers are called the ionospheric layers. What is layers? Because there are different density is in there, so there will be different amount of ionization. So depending on the amount of ionization, we define different layers. So layers is at different heights, there will be different ionization. So these layers they vary with location on Earth, with respect to Earth. So what is its location, what is its height, what is the time of day. So midday it will be maximum, morning it will be minimum, evening it will be minimum, night it will be completely less. And then what is the time of the year? Summer season you will get more layers, winter season, rainy season, particularly winter season it will go down because the atmosphere is cool. So that happens. Then sunspot activities. The channels that I referred, please go through those channels. You will understand what is sunspot activities from that. So that also affects the electron density distribution. So these are the factors which affect the electron density distribution in the ionosphere. Now what are the layers? Layers have different names. These are regions around the peaks of the density. So if I get one peak, I will call it E layer, then the next peak I can call it F layer, lowest peak towards the Earth, so which is the D layer. Now the F layer usually splits into two parts in the daytime, F1 and F2, because we have maximum energy, it is in the upper part. Lower part is D layer, upper part is F layer. In the night there will be no sun is absent, therefore they merge. F1 and F2 they merge to give you F layer. In the daytime they can split to give us F1 and F2 layer. So this is about what is layering, what happens in the ionospheric activities. Now let us try to see what will happen if there is charged particles in the ionosphere or in the atmosphere. When we have charged particles in the atmosphere, then and if we apply electric field to a charged region, gas charged region, that gas charged region is said to be ionized or to be in the state of plasmonic state. Now in that state, what is going to happen? Let us see. So assume that the electric field that we are applying is in the x direction, right? And the mass of the ions, positive charge is very high compared to the electrons. So the ions are not moving, but electrons are moving because their mass is less. So it is much greater than mass of ion is much greater than that of electron. Therefore motion of ions we can safely neglect, but the electrons will move. So if we are considering motion of electron, then what is happening that or what will be the its effect in an electric field, motion of electron, how it is controlled, that is something that we are going to see. So for that we will see that if there are charged particles and electric field is applied, then the space in that region is no more free space, it is having its own dielectric constant. we are going to find out that dielectric constant, and this charge particle region under the influence of electric field is a plasma. So that dielectric constant we will call the dielectric constant of a plasma. Now we know, as we have studied in antenna also, we have revised this portion. What is a polarization vector P? P is by definition P is equal to minus Ne into P, small p or little p vector. And what is little p? It is E into D. That is the E is the charge and D is the distance. Now electric field is applied along D. D is equal to x into x cap, we can say. Now Ne is electron density per meter cube. E, you know, electronic charge is 1.59 10 to the power minus 19 coulomb. D is average displacement between positive and negative charges, and that we know, small d. So considering all these, the relative dielectric constant epsilon r by definition is d upon epsilon 0 into E, or as you know, d is equal to epsilon 0 E, or d is equal to epsilon r E, d is equal to epsilon E, epsilon is equal to epsilon 0 into epsilon r E. So from that you can find out epsilon r is equal to d upon epsilon 0 E. Now what is d? Using polarization vector, d is given as epsilon 0 E plus p, polarization vector, divided by epsilon 0 E. Now divide it by epsilon 0 E, so first part will be 1 plus polarization vector divided by epsilon 0 into applied electric field. So this is how you will find out the relative dielectric constant. And then propagation constant within the plasma. The propagation constant we know, we define it as gamma, which is equal to j kc. Kc is the wave number, cutoff wave number kc. Kc is defined as omega upon c root over of epsilon r, and omega upon c root over of epsilon r, that you can also write as j k0 into n. N is refractive index or index of refraction. Omega by c is equal to k0. Why omega by c is equal to k0? That you know, omega is equal to 2 pi f. So 2 pi f by c, f by c is lambda 0, 1 upon lambda 0. So 2 pi by lambda 0, that is k0. So gamma is equal to j k0 eta or j kc. Kc is equal to k0 eta, k0 n. Kc is equal to k0 n, and for free space Kc is equal to k0 as n is equal to 1. Why n is equal to 1? N is defined as root over of epsilon r. In free space epsilon r is equal to 1. Therefore n will be 1. That is index of refraction. Both these two quantities, epsilon r, that is relative dielectric constant, and the index of refraction n, which is the square root of epsilon r, both these can be complex. In general they will be complex. So if they are complex, then you can write epsilon r is equal to epsilon r dash, which is the real part, minus j epsilon r double dash, which is the imaginary part. Now why there is a minus sign? That indicates the loss. In the dielectric there will be some amount of loss because of the imaginary part, and that is related to conductivity, that we will see later, or that you are expected to have read earlier. So epsilon r is in this form. If epsilon r is in this form, then root over of epsilon r will be n, which is equal to n dash minus j n double dash. So this is how you can express epsilon r as n, that is the relative dielectric constant and the refractive index. Now let us come to the electron, which is in motion. If it is in motion, it will definitely obey the laws of motion. So the equation of the motion for the electron will be of the form, as you know, laws of motion. What is laws of motion? Laws of motion says F is equal to mass into acceleration, or that gives you the force balance on both the sides. So F is equal to mass into acceleration plus any other force. Now mass into acceleration is m into x double dash, as I have told you. D is equal to x cap. D is in the direction of x. Alright, that is what we have assumed. So we have assumed x polarized electric field. So electrons must follow the electric field in their motion. So if they are following the electric field in their motion, then D will be x into x cap. So if D is equal to x into x cap, then acceleration will be x double dot. X double dot is dx d square x by dt square. So m into x double dot. Then plus nu m x dot. That comes from the friction, or that comes from the collision. So if there is collision, when there is density, so these are free to move. The electrons are free to move while they are moving in the gaseous medium. They will collide with each other. Because of the collision, there will be restriction in motion. So these collision forces are like frictional forces, which is opposing the motion. So this is to be added to find out the total force. So that collisional force or frictional force is nu into m into v. So nu into m, v is x dot. So nu into m into x dot, that will be the applied force. So applied force, charge into field. Q into E is the force. Now charge is minus E, field applied is in the x direction, so Ex, time variation is e to the power j omega t. So that is electron's equation of motion. Now in this, mass of electron m is equal to 9 into 10 to the power minus 31 kg. That is electron mass. Then nu is called the collision frequency. Collision frequency is how frequently one electron is colliding with any other electron. That is the average of that. So that gives you the collision frequency. Now for this type of equation, differential equation, solution will be of the form, solution for x will be of the form a e to the power j omega t, exponential j omega t. That is the solution of x. If I put that value x, value in the equation of motion, so what I will do is find out x double dot, which is minus a omega square exponential j omega t. Find out x dot, which is j omega a exponential j omega t. Put those values in the wave equation. So I will get m into minus a omega square exponential j omega t plus nu m into j omega a exponential j omega t. That will be equal to minus e then ex exponential j omega t. Cancel out exponential j omega t from both the sides. Take a common and divide on both the sides the coefficient of a on the left side. So that will solve for the constant a. So a will be little e, ex. Ex is x component of the field divided by m omega square into 1 minus j nu divided by omega. So that is my a. Once I find out a, then I can find out what is the polarization vector. Polarization vector is how the electrons are getting polarized. That is found out by the number of electrons per unit area, so per unit volume, which is Ne into charge of electron, which is E minus E, so minus Ne into E, and in the direction where it is polarized, in which direction it is polarized, that is x. So minus Ne into E into x vector. Now we have found out what is the x vector. X vector is equal to a into e to the power j omega t. A expression we have found out, so put those values here. So minus Ne into E into a into exponential j omega t x cap. So that will be the rightmost expression. Just I put the value of a. Now that let me try to simplify this expression or find out a simple expression for that. So to do that, we define a plasma frequency omega p, which is equal to root over of Ne into E square divided by m into epsilon 0. So what we are doing is here, we are multiplying on the right hand side, we are multiplying epsilon 0 in the numerator and denominator. Then we are taking Ne into little e square divided by m into epsilon 0. That part we are considering as omega square p, and omega p we define as plasma frequency. So let us define that way. So once we take out that plasma frequency part, then what will be left is the rest part into epsilon. So we will define a constant x is equal to omega p by omega square. You can see in the denominator there is omega square. So that we are taking into account omega p by omega square. Then the rest of the thing is taken as g. So z is equal to nu by omega. If I use these two constants and omega p, then my polarization vector, this polarization vector, we can rewrite it as minus epsilon 0 Ex exponential j omega t. So that part is taken care of. X cap, it is in the direction of x. Then capital X upon 1 minus j into capital G. So now we have found out what is the polarization vector. Now let us try to find out what will be the dielectric constant. We know epsilon r, in general it is complex, so epsilon r dash minus j epsilon r double dash, that is equal to n square. Now that we are going to write as 1 minus x by 1 minus jz. That comes from our expression for polarization vector, that which we have seen in the previous slide. So that we can write as 1 minus omega square p upon omega into omega minus j nu. Just put values of x and z, simplify that, that is going to give you this. Now from this we can find out an equivalent conductivity by considering that epsilon r can be written as epsilon r dash minus j sigma, which is the conductivity, upon omega epsilon 0. Now if I compare these two, the lower equation with upper equation, we can easily see that sigma will be what and epsilon r dash will be what. Epsilon r dash will be 1 minus Ne E square upon epsilon 0 m nu square plus omega square, and sigma will be Ne E square nu divided by m into nu square plus omega square. Denominator in both the cases are same, except in the first case by epsilon 0 is multiplied. Numerator is almost same, Ne E square is common, nu is multiplied for sigma. Now if I consider a special case where we assume that the electrons are moving, they are polarized, but they are not colliding with each other. So there is no collision. If there is no collision, then collision frequency will be 0. So eta will be 0. If we put eta 0 in the above, sigma will be 0. Then epsilon r dash will be 1 minus Ne E square divided by epsilon 0 m into omega square. So using that, we can get what is Kc. Kc will be omega root over epsilon 0 mu 0 epsilon r, this we know expression. Now put the value of epsilon r there. Epsilon r will be 1 minus omega square p by omega square root over when nu is equal to 0, and k0 remains. K0 is equal to omega root over of mu 0 epsilon 0. So that gives us k0. So Kc will be this. Now we will consider some special cases from that. Now if omega is greater than omega p, then the expression for Kc is real, because it is 1 minus omega square p by omega square. So omega 1 is greater than omega square p by omega square, so always 1 minus that value will be positive. So Kc will be real. If Kc is real, exponential minus jkcg will be exponential minus jkc. So that will be remaining as it is. So you will get a propagating wave. But if it is not real, which is the case when omega is less than omega p, so if omega is less than omega p, Kc is imaginary. Kc is imaginary. So if Kc is imaginary, then this e to the power minus j Kc, g will be Kc is imaginary. So Kc will be j kappa c. So j into j is 1 minus 1. So that will give us exponential minus j Kc g, which is an attenuating wave or evanescent wave. It is not a propagating wave. So if omega is less than omega p, omega means operating frequency. If the operating frequency is less than plasma frequency, then the wave will not propagate in the atmosphere. So atmosphere will attenuate it or reflect it. If omega is greater than omega p, it will propagate through the atmosphere, so it will pass through the atmosphere or ionosphere. So it is not coming back to the earth. For coming back to the earth, we require omega to be less than omega p. Now when omega is equal to omega p, then Kc will be 1. This is called the critical frequency. The frequency at which this occurs, the omega for which this occurs, omega c is equal to omega p, that is called critical frequency Hc. That is approximately 9 root over of Ne max. So from where 9 comes, just put the values of Fc, whatever values are there, m is there, electron charge is there, put those values, and that will give you about 81 root over of 81 Ne max. So 81 is approximately 9. 81 is 9, so this will be approximately equal to 9 root over of epsilon max. Now on the critical frequency, what is the critical frequency? What does it physically signify? It signifies that when the propagation constant is 0, or this is the frequency where the propagation constant is 0, Kc is equal to 0. Now if we neglect the effect of magnetic field on Earth or Earth's magnetic field on this propagation, this critical frequency will occur at the plasma frequency. Omega is equal to omega p or omega c is equal to omega p. And therefore these two terms, the plasma frequency and critical frequency, these two terms can be used interchangeably. Whether we call critical frequency or we call plasma frequency, they mean the same thing. At the critical frequency, the wave is actually reflected back to the earth. Now you have seen that omega c or critical frequency or omega p, this depends on the altitude. Why it is depending on altitude? Because density goes down, atmospheric density goes down as you go up. Therefore, and it depends on the density Ne max. So it depends on the density. Density depends on the altitude. Therefore, omega c depends on the altitude. Now, since it depends on the altitude, for electrons, the highest frequency at which a reflection occurs is the critical frequency. And reflection at normal incidence requires the greatest Ne. So if we look at the earth, if we look at the earth and we are incidenting onto it, from the earth you can see above the earth we are showing in the dotted line, the portion bounded between the two dotted line is the ionosphere. Below that we have normal atmosphere, above that we have normal atmosphere. In the ionosphere we can have omega, when omega is equal to omega c, that gives epsilon is equal to 0 in the ionosphere. And if I transmit something vertically upward in the earth, that will come down when omega is equal to omega c from the ionosphere. So that gets reflected back to the earth. So the point from where it comes back is called the reflection point of the ionosphere, and the height up to which it goes is called the virtual height, or h dash. So from that point, that is the reflection point from which it will come back to the atmosphere. So this is all about dielectric constant of the plasma or ionospheric region. So we'll take a break now. Let us take a break for 5 minutes, try to understand what we discussed, then we'll come back and start again. Little bit. Bathroom again. First class सरीगला अध घंटा छाड़देला घर माता फोन रे व्यस्त अच्छा माता को डाक रागिली कौन रागिली के आरंभ रागिली के मत लगे फोन थाऊ से कथा पूजा कर पूजा बाटी देके आइली डाटा कलेक्ट कर कौन होता तुम तो पूरा पाइलानी कोरोना कहवा दरकार ना